Thank you, Al. So I was asked when this conference was first being mooted whether I could come along and talk a bit about what we do in first year chemistry. That's sort of one of the points of this whole stream today, is to try and reinforce the links between high schools and universities. And so it probably made sense for me to come and talk a bit about what we do in first year chemistry, and some of the issues associated with how we do it, the numbers and everything. So what I want to do is just quickly go sort of through 2 first year papers that we teach here, some of the sort of vital statistics of them, and then talk a bit about some of the issues that we face with teaching these papers and some of my thoughts about what we can do about them. So, the main course that students come to Otago to do is now called Chem 191, which has got a bit of a mouthful of a name, the Chemical Basis of Biology and Human Health. Chem 191 is part of the Otago Health Sciences first year program, which is 7 compulsory papers that students must do if they want to go on to professional courses in medicine or dentistry or physiotherapy or various things. Because of that and the impressive marketing abilities of Otago University, the classes are very big. This year we had 1,536 students sit the exam. We topped out about 1,680, I think, so about a month into the course. So there's lots of students. We're not the biggest paper either by some distance. One of the bulky papers is 1,800. So big classes, lots of students. The way the course works, we have 36. We have a total of 47 lectures this year. 36 of those are taught by chemistry. 4 of those are taught by biochemistry. One of the things about the first year health science program is that each of the 7 papers are contributed to by different departments to a greater or lesser extent. In some cases there's a lot of overlap, in other cases there's less. We're mostly taught by chemistry, but there's also some biochemistry in there as well. And we also have these things called hot topic lectures, which are designed to show the students how the chemistry or the biochemistry that they're learning about in their lectures is relevant to some of the research that's going on in the university. And so sort of guest lecturers come in to give lectures on particular topics that hopefully, and in many cases do, relate to the chemistry that they're being taught in the classes. And so chemistry, biochemistry and also pharmacy contribute to these hot topic lectures. As a part of the first year health science program, we have fortnightly labs. This was part of the new style of the way it's taught. It's not ideal for us. We would like to have a lot more for practicals, but the reality is with the numbers, it actually was a blessing in disguise, because in 2004, which was the last year of weekly labs, it was 2004, it was virtually unworkable. We were running 44 lab streams a week, and it was just a nightmare. So fortnightly labs is kind of a blessing in disguise for us. And then tutorials. We don't stream tutorials, obviously, because there's an awful lot of students. When I first started, I would run tutorials for students who have very poor chemistry backgrounds, of which even then there's a lot. So even then it was a first served basis, and I ended up doing about 13 of those a week, as well as labs and everything else, and it just got a bit unworkable. So we changed that, and now what we have is something called drop-in tutorials, where we have a room not unlike this, available for periods of 2 hours a week, so students can come along and get help. And of course, predictably, no one comes except for right before the exam, when you're overloaded and you can't really help anyone very effectively. So for most of the first part of the semester, I in fact sat and read John's thesis in these tutorials because I had lots of free time. But in principle, they're a good idea, and the students who do come regularly, and they get a lot out of it. Very briefly, the outline of what we teach in 191. It runs in 6, this year at least, around 6 modules. So a module on energetics and equilibrium, not thermodynamics, energetics and equilibrium in biological systems. The underlying theme of all of this has to be the way that chemistry impinges upon biology, because this is one of the mandates of the first year health science program, is that it's all supposed to be about the ways in which the different aspects of science help us understand how biological systems work. We do this to a greater or lesser extent depending on the modules in question, but in general that's supposed to be the thing. So energetics and equilibrium biological systems, so we look at thermodynamics and delta G and equilibria, solubility and acid-base chemistry in there. And then a small module on kinetics, a bigger module on coordination chemistry and metalloproteins, which is where the redox chemistry comes into it, but in the context of biological systems. Then a big section on carbon chemistry, so-called, so stereochemistry, organic reaction mechanisms, and then we look at a bunch of different reaction types in terms of the reaction mechanisms, so trying to have an underlying understanding of how, on a molecular scale, the reactions work. Then there's a module on biological molecules specifically, so amino acids, proteins, peptides, oligosaccharides, and then also a little bit on aromaticity and nucleobases as well. And then finally this year we had a small module that was the contribution from the biochemistry department, where there were 4 lectures talking about proteins and some case studies of proteins. I should say, because some of them I can get later, that we're changing this a little bit for next year, so that these biochemistry lectures, rather than being a cohesive block at the end, are going to be scattered throughout the course. So one of the things the students commented to us was that they didn't really see the point of doing the biochemistry at the end. It's supposed to be relevant, it is relevant, but they've forgotten what they did a month ago. So we're going to split them up and make them much more targeted where we put them, to make it much clearer to them the relevance between the relationship between the biochemistry and the chemistry. We have the 6 labs. Here are the 6 labs. Of necessity, they tend to be a little bit boring to some of them. To some of the students, this is all very new and scary, and for other ones, they've kind of worn their way through it. But there's all sorts of reasons, like John talked about earlier, about that impinge upon what we can do and how we can do it with a class of 1,600 students. So that's those. The way we assess the course, a mixture of exit tests in the labs. So at the end of each lab, the students sort of sit a short test, which is then goes towards 15% of their assessment. We have a terms test, which is an hour multi-choice exam in the middle of the semester, which is 15%, and then a final exam, which is a mixture of written answers and multi-choice at the end. Okay. Chem 191 has this very bad rep. It's apparently everyone fails. You keep hearing these things, everyone fails. In fact, everyone doesn't fail. About a quarter of the class typically fail. We normally pass